Alright, today we're going to learn about ellipses.
Oh cool, you mean the thing with the sun and the moon where the sky gets dark and I can't see anything?
No, silly. Those are eclipses. I'm talking about ellipses. A circular shape we study in mathematics. One of the four conic sections. You remember conic sections? The different shapes we get when we take a cone and slice it up in different directions?
Oh, you mean ovals? That it looks like an 8?
No, not really. See, ovals can be any rounded shape, like taking a rectangle and rounding out the edges. The shape of an ellipse is very specific and very special. Not all ovals are ellipses. Actually, the elliptical shape has a very unique property that's used in many things, like astronomy, physics, aerodynamics, optics, medical equipment, and architecture. In fact, the coolest thing about architecture has all to do with the ellipse. Pretend we're at St. Peter's Square in the Vatican City. If you were to stand at that one fountain on the left, and I were to stand at that one fountain on the right, we could whisper back and forth to each other. You'd hear me clear as day.
What? How could that happen? You'd have to shout!
Nope, I could whisper to you, thanks to the properties of an ellipse. See, the fountains are placed on the foci of the ellipse. Sound coming from one of the foci points will always bounce off the walls of the ellipse directly toward the other foci point.
A foci? What's that?
Foci. That's the plural for focus. One focus point, two foci points. Let's start with a circle. A circle has one focus, although we just call it the center. And no matter where I move along my path, I will always be the same distance from that center. See how my string is always the same length and never changes?
Oh, the string is like the radius.
That's right. There's the center, the radius, and the path that makes the circle. An ellipse is slightly different. Rather than having just one center, it has two foci. So this time I'll use two pins and attach each end of the string to the foci, leaving some slack for my pencil to go around. And voila, an ellipse. What did you notice about the string this time?
The string stays kind of the same length as the radius, but it bends.
Good. If you take any point on the path of the ellipse, the sum of the distances from that point to each foci will always be the same. We call that length a constant because it never changes, just like our string. See how the blue and red paths always add to the same length? Let's look at some more important parts of the ellipse. First is the line along the length of the ellipse through both foci, which we call the major axis. Drawing a line along the width of the ellipse gives us the minor axis. Where the two axes meet, in the middle is, you guessed it, the center. The 2 points where the major axis intersects the ellipse are the vertex, or we call vertices. And finally, the minor axis intersects with the ellipse to give us the covertex, or covertices. Sometimes you'll see ellipses turned vertically, but all the parts are still the same. The longer of the two axes is still called the major axis, and the shorter of the two is the minor axis. Again, the two vertices are at the ends of the major axis, and the covertices at the end of the minor axis. Now it's your turn to try. Good job! We'll see you next time.